Assalamualaikum students. Today, students, we are doing electrolysis, right? What is electrolysis? Electrolysis is the decomposition of an electrolyte by passage of current. Now, what is the meaning of this? What is an electrolyte? Look, if I have salt and I put this, and we just check that whether the salt can conduct electricity. No, salt cannot conduct electricity. But if I put the same salt in water, it will dissolve. The salt contain ions. The ions will be free to move, and now it will conduct electricity. It will not only conduct electricity, there will be decomposition of the electrolyte by the passage of this current. So if you are passing current and there is conduction of electricity and there is decomposition of an electrolyte, it's a chemical change. And at the same time, one thing, that you are passing current and a reaction is occurring, it's a chemical change, it absorbs energy, it's endothermic. So now I'm sharing my screen and I'm going to explain that how it happens. How do we write reactions? What is electrolytic cell? Everything, right? Okay, now coming to the electrolysis. The definition. What is electrolysis? What is electrolysis? The decomposition of an electrolyte. The decomposition of an electrolyte, which could be molten or aqueous, by the passage of current. Now, what is an electrolyte? What is an electrolyte? Substance that conduct electricity in its molten state or aqueous solution. I will share the notes. Substance that conduct electricity in its molten state or aqueous solution due to freely moving ions. And it is also decomposed. Since new substances are formed, new substances are formed. It is called what? A chemical change. And second, look, if I put salt in water, the salt will dissolve, and then if I evaporate the water, salt will left. It's a physical change. But if I pass current, new things will form. If new things are going to form, it's a chemical change. It needs light, electricity. Sorry, not light, current. It needs electricity, current. It is endothermic. It is endothermic. Now, electrolytic cell. In every electrolytic cell, look, this is the beaker that contain, first thing, electrolyte. And what should be the physical state? It is molten or aqueous. What is there inside it? Ions. Freely moving ions. There are cations, there are anions. Right? Now, this is DC power source, DC, direct current, not alternating. Connecting wires, these are called electrodes. Connecting wires, electrode. Look, the first thing, DC source, provide energy, right? Direct current. Keep in mind, this longer one is always positive, the shorter one is negative. It's a DC source. This electrode is connected to positive. This electrode is connected to negative. The one that is connected to positive is called anode. Why it is called anode? Wait a minute. And the one which is connected to negative is called what? Cathode. Right? Now these are what? Metal wires. And they conduct electricity. Why? Because of delocalized electron. Look, in the external circuit, electron inside this place, ions. Like in the outer circuit, electron in the inner circuit, ions. Now next point. What are electrodes? Wait a minute. What are electrodes? You know, electrodes are actually, electrodes are terminal. Let me put off the fan. Wait. Electrodes are terminals through which electron enter or leave the electrolyte. Right? Electrodes must be unreactive and conduct electricity. So, what are the things that fit to these requirements, like unreactive and conduct electricity? Platinum and graphite. They are both unreactive and conduct electricity. So, look, the electrodes are the terminals through which electron enters or leave the electrolyte. You know what happens? The first point. This is cation. It moves to cathode. CAT and CAT. It's a deliberate act. Cation moves to cathode. Anions move to anode. Look what is happening. Anion move to anode. Anion goes to anode. Anion lose electron, get oxidized. oxidize. The anion, which is negative, it moves to anode, which is positive. It loses electron. The electron goes this way, and they are coming from positive toward negative to the external circuit. The electrons are lost by the anion. They come all this way toward the cathode, where the electrons are accepted by what? Huh? The electrons are accepted by cations. Cation gain electron. Cation get reduced. Look, anion get oxidized, they lose electron, the electron come here and they are accepted by the cations, which are what? Positive. They move toward negative. Anions are negative, they move toward positive. So during the whole process, electricity is coming from DC power source. There are cation and anions. These are electrodes. These are connecting wires. They bring the electron in and out. They enter through these electrodes. And now the anion lose electron. The electron go all the way from anode toward cathode, which are accepted by the cation. So electron lost by the anion are electrons gained by the cation. Right? Now, we can write that anion, they go to anode where they lose electron and get oxidized. Cations go to cathode where they gain electron and get reduced. Now, next point. The electrolyte to which we are dealing, it could be molten, it could be aqueous. Now, molten and aqueous, these are two different cases. We have to deal them. We must know how to write the reaction, what happens to electrolyte. But first thing, we must know all the reaction. We must know all the reactions before dealing with molten and aqueous. All the reactions occurring at electrodes. So what are the reactions? Look. Cations go to cathode. Which cations are in your course? Knights, Knight, Knights of Norway, called Mr. Asif Zardari from Sindh, Pakistan. He has copper, silver, and gold. More than this. These are the cations that are in your course. What? Knights of Norway, called Mr. Asif Zardari from Sindh, Pakistan. He has copper, silver, gold. right? These are all the cations that you will deal in either molten or aqueous. Keep in mind. Now, one thing. Whatever is your cation, it has certain charge. It will gain electron equal to the charge of the cation and will turn into metal. The metal deposit at cathode. Look what? Suppose this is Na plus, so gain what? One electron, making sodium metal. But if it is Mg, 2 plus, it will gain how many electron? 2. Why? Because the charge is 2. So it will turn into magnesium metal. If it is aluminium, 3 plus, it will gain how many electron? 3, turning into what? Aluminium metal at cathode. So the charge and electrons are same. And there is another thing in the metallic series, that is hydrogen, H plus. So what is the charge? 1 plus, gain 1 electron, making hydrogen atom. Another hydrogen at the same time will also gain another electron, making hydrogen atom. At the end, what will happen? There are 2 hydrogen. It's not good. How many hydrogen? 2H plus. How many electron? 2 electron. Making what? H and H. They're not going to make 2H. It's what? H2. Hydrogen gas. Bubbles of colorless gas at cathode. So if I write all the equation, like when you will deal the molten and aqueous, if you know the reaction already, like it would be quite easy to proceed with, right? So what is the reaction? Plus 1 electron, potassium metal, plus 1 electron, sodium metal, plus 2 electron, calcium metal, 2 electron, magnesium metal, 3 electron, aluminium metal, 2 electron, zinc, 2 electron, iron, 2 electron, tin, 2 electron, lead. What you will do for this? 2 and 2 electron, and what will form? H2. And what about copper? 2 plus, 2 electron, copper, 1 electron, silver, 2 electron, gold. This is gold. So when we say that the cation move to cathode, gain electron, and you're supposed to write the reaction is always one of these. What about anions? Come. Anions. Anion goes to what? Anions go to anode, lose electron. Now, like there is this thing for cations that they're called what? Numenics, I think. The Knights of Norway, but I don't know for anions. I just do it like this. Look, if you go to periodic table, there is this fluorine, chlorine, bromine, iodine. This is group 7. So what I do? It's fluoride, I write oxide and sulfate and nitrate. The rest is same. And then hydroxide. So how? Look, fluoride, oxide, nitrate, sulfate, chloride, bromide, iodide, and hydroxide. Now look, this is fluoride. What is the charge? -1. It will lose one electron, become fluorine. Another fluoride at the same time lose one electron equal to the charge, fluorine. So what is the overall equation? 2 fluoride lose 2 electron, making what? F2. Exactly same. Chloride lose electron, making what? Cl. And other chloride lose electron, making what? Cl. So what is the final result? 2 chloride, 2 electron, and Cl2. Same is for bromide, same is for iodide. And what about oxide? Look, 1 oxide. Lose how many electron now? 2 electron. Why? The charge is 2. And O, another oxide. Lose 2 electron and O. So what is the final? 2 oxide. They lose 4 electron. 2 plus 2. And what is formed? O2. So if I write this equation, 2 will lose 2 electron, making what? F2. 2 will lose 4 electron, making what? O2. Their reactions are not in course. They never lose electron. But we have to write this because they ask us that your electrolyte is potassium sulfate. Now, there are potassium ion from this, there is sulfate ion. But even if there is sulfate, it is not going to lose electron. This you are not supposed to know. But you have to write this for the sake of the electrolyte. You must know that what are the ions, right? This I'm going to explain in the next lecture, right? But what about chloride? 2 chloride, wait. 2 chloride, 2 bromide, 2 iodide. And each losing how many electron? 2 electron, 2 electron each. No, not each, both. 2 electrons. And what is formed? What is formed? It's Cl2, it is Br2, it is I2. Right? Now, next. For this, you have to memorize 4 hydroxide, 4 electron, 2 water, and oxygen. You have to memorize. Now, this one is what? Pale yellow or colorless gas. This is what? Colorless bubbles or gas. Green yellow gas at anode. Red brown gas or orange, even you can say orange. Purple vapors. Colorless. Colorless gas. Now look, if the metals gain electron, metallic deposits. If hydrogen gain electron, bubbles of colorless gas. But these are reactions of cathode And these are the reactions of anode. Like if you know that in your, for instance, wait, this is container. This container contain what? Aluminium oxide, molten liquid. So in aluminium oxide, there are aluminium ion, this will be the reaction, and oxide ion, this will be the reaction. So what is there inside the container? There are aluminium ion, there are oxide ions, and this is the DC source, the positive, the anode, and this is the negative, and this is what? Cathode. Now what is going to happen? Anion will go there, lose electron. So 2 oxide will lose 4 electron, making what? Oxygen gas. So oxygen gas will evolve. The electrons are moving this way to this. The electrons are moving from positive toward negative. Keep in mind, in the external circuit, from positive to negative, the electrons are coming all the way to cathode. They are gained by what? Aluminium. What the aluminium will do? It will gain 3 electron, making aluminium metal. So, aluminium metal at cathode, oxygen gas at anode. So, if I look at the reaction, the aluminium is gaining 3 electrons, making aluminium metal. The oxide are losing 4 electrons, making what bubbles of colorless gas? One thing which they don't ask usually, like there are very, very less question on this thing, that electron gain must be equal to lost. It's gaining, it is losing. They must be equal, right? There are very, very less question on this thing, but still we can say that, like we can't say that there is no question. Yes, this point is sometimes touched, right? So if I have to equalize the electron, what am I supposed to do? I will take this 4 and I will multiply this whole with 4. So when I will multiply this 4, it 4 ones are 4, 4 threes are 12, 4 ones are 4. And I will multiply this whole with 3. Look, I will multiply this whole with 4. I will multiply this whole with 3. Look, multiply this with 4, multiply this with 3. So it becomes 4 into 1. Multiply with this place only. This 4 ones are 4. Not with the charge. 4 ones are 4 aluminium. 4 threes are 12 electron. And 4 ones are 4 aluminium metal. 3 twos are 6 oxide. 3 fours are 12 electron. And 3 ones are 3 oxygen. So if I make the overall, anything same from this side with this side would be cancelled in the overall. First of all, what I'm going to do, this is the arrow place, so I will put the arrow. Arrow. The electrons are cancelled. This is 4 aluminium with 3 plus. This is 6 O2 minus, making 4 aluminium and 3 O2. If you look, 4 threes are 12, 6 twos are 12. Like plus 12 and minus 12, they are equal. The charges are equal. The electron gain and loss are equal, right? So our next topic is what? If the electrolyte is molten, then what we will do? If it is aqueous, then what we will do, right? I think this is sufficient for now, right? Allah Hafiz. See you.